Everybody, welcome back to another fun and exciting Algebra 2 class. Today we're going to be on page 305, and we are going to be talking about matrix inversion. I don't know if you remember a couple lessons ago when I was talking to you about inversion, about inverting matrices, and I said just wait because we're going to get to it here in a couple lessons. Well, here we are. What is it? What is matrix inversion? Let's look down here at the screen. The inverse property of multiplication says that anything multiplied by its multiplicative or multiplicative inverse always equals 1. What does that mean? Well, in baby math, we learned that 2 times 1/2 equals 1. So we could do that, 2 over 1 times 1 over 2, and these are going to cancel out. That's the thing about the multiplicative inverse is when you flip it, it always cancels out. So it always equals 1. Doesn't matter what it is, 3. So if we do 3 times 1/3, it's going to cancel and it's going to give you 1. It always does. It has to. That's a rule. It's a law of mathematics. So here, let's look at this next one. Okay, now this is a concept that we've just added here in Algebra 2. I don't think we talked about it in Algebra 1, but anyways, this idea of the -1, what does that mean? Well, it means 2 to the -1. How do we get rid of that? Well, we have to flip that 2 down to the bottom, and we remove the negative sign, so you don't even need this anymore, so 1 over 2. So this means, right there, that means 1/2. Because what does that -1 make you do? It makes you flip the 2 into the bottom. Basically, you're inverting it. Okay, so again, it equals 1. This is the same concept. These two things are the same concept right here, so don't be confused by those. I just wanted to show you both of those because this is the concept right here that we're going to be using with the matrices. All right, so if in a matrix, if we have a to the -1, remember we have the A matrix, okay? A equals, 2, 1, 3, 4, for example, okay? So that's the A matrix. Well, to invert the matrix, okay, to the -1, so if we want to get A to the -1, how do we do that? All right, that's what we're going to learn in this lesson. That's the what, that's the how. So in matrices, A to the -1, so that's like this right here, that's the inverse. Now notice, this is something that should work every time. If we have A times A to the -1, what should we get based on this? Based on this, we should get 1 as our answer. Now, in matrices, that looks a little bit different. We don't get 1. That doesn't work like that. Here's what we get. Let me show it to you right here. We get what's called the identity, or we get that's called the identity matrix. And maybe I should write that somewhere else so you can see it just a little bit better. Let me write it right here. It looks like this. It looks like 1, 0, 0, 1. This is the identity matrix, okay? Well, with the discriminants, you see here 1 times 1, and then here is 0. 1 minus 0 equals 1. So if we did the determinant, what would the determinant be on this one? We multiply here and we get 1. Minus, multiply here and get 0. 1 minus 0 equals 1. So this actually does give you 1. The determinant is 1. So this is what's called the identity matrix. It's very important that you know that identity matrix. It's in your book on page 305. Okay. So coming back up here, make sure that you know that when you see this right here, that wants the inverse of the matrix. Okay. So A1, B1, C1, whatever matrix that you're talking about, they want the inverse. It's the multiplicative inverse of A. All right, so I put it like in common people talk right here. In other words, when A to the -1 and A are multiplied together, they give you 1. Now, the way it gives you 1, like I just showed you right here, is through the identity matrix. So basically through the determinant is 1, but it does give you 1. This equals this. These are the same thing. Okay, when you multiply this out, it is 1. So it does give you 1, but it looks a little different than just the number 1. It gives you 1 as far as in a matrix form. Okay, so this is called the identity of the matrix, or the I. Whenever you see the capital letter I when dealing with matrices, you're going to know, okay, that's my identity matrix. That's that 1, 1 for the diagonal, and then the antidiagonal is 0, 0. And this is only with 2 by 2s, okay? So this is, again, we're dealing with 2 by 2s right now. There are other rules that apply for different types of matrices, but we're dealing with the 2 by 2s. All right. Now, the next word that it goes over in your book, and this is on page 305 near the bottom of the page, is called the adjective matrix. The adjective matrix. What is that? Well, the adjective matrix is basically a shortcut to finding the identity matrix, okay? So if we want to find, and here's the thing, you say, well, I know the identity matrix, it's right there, it's 1, okay. But I'm talking about, what do you multiply by? See, it was easy when it was like this. I'll do it right here. When it was 2 times 1/2. When it's numbers, it's easy. But here's the thing, and remember that gives you 1, equals 1. But now when you have a matrix, it's 1, 0, 2, 4 times what gives you 1? And you might say, well, times this gives you 1. No, no, no. That's the 1, okay? That's the 1. This is the identity. That's the 1. The question is, what's the 1/2? What do we need to multiply by to get the 1? Okay, so that's what we're talking about right now. What do we multiply by? And it looks different in matrices. In regular numbers, it was easy. It was like, okay, if it's a 3, then we multiply by 1/3. It's not that easy in the matrix math. So we had to have some steps. How are we going to do this? The first thing that we need to do is we need to learn how to do the adjective matrix. What is the adjective matrix? Well, again, it's the shortcut that we're going to use to find the identity. So the first thing that we want to do is multiply A12 and A21 by -1. In other words, change the signs of A12 and A21. Okay, what do I mean by that? Well, let's go down to this. Okay, here's our matrix, and we're gonna form the adjective matrix. Okay, so we want to form this adjective matrix. How do we do that? Well, you're thinking, well, what is it even for? Don't worry, we're going to get to what it's for, but you have to know how to do it before you can use it to find the identity. So let's just figure out. So here's what we're doing. A12 and A21, we're changing the signs. So there's A12 and there's A21. We're just going to change the signs. These were both positive. So now in our new adjective matrix, those are going to be negative. So negative A12 and negative A21. Okay, that's the first step. There's only 2 steps. This isn't very hard. The second one is just switch B11 and B21. So, well, I don't know why I switched to B right there. That was, oh, I think I know, the book shows it in B. I'm showing it in A. Sorry about that. I should say A. There we go. So A11 and A21, we're going to switch those two. So here is going to be A21, A22, and here is going to be A11. This is our new adjective matrix, so we've switched some things around. Okay, we took our original matrix and we multiplied A12 and A21 by -1, and then we just swapped places for A11 and A22. Right, so what does this look like in a regular matrix with numbers? Those were just kind of the letter designations. So let's actually do this. So this is going to equal, how do we do our adjective matrix? Well, we take these two and we multiply by -1. So that's going to be -2 there and -3 there. Then we just take these ones and we swap them, 8 and 5. Okay. what we have done is we have created what's called an adjective matrix. Okay, there it is right there, that word, adjective matrix. That is part of our, that's a step. Basically, here's what it is. It's a shortcut to us finding the inverse. Okay, so now if you can find the adjective matrix, then you can go to the next step, which is finding the inverse. All right, so let's go ahead and talk about the inverse. You guys are at a level of math. Check this out. You're at a level of math where it's saying, no, that is not spelled right. That's not even a word. You're learning about things that spell check doesn't even know about, okay? You see that little line underneath there that's saying, that's not a word. What are you thinking? Well, it is a word. It's a math word, okay? It's adjective, and it is a real word. But spell check doesn't know about it. You know more than spell check now. So steps to finding the inverse. How are we going to find the inverse? All right, here's what we want to do. Step number 1, find the determinant of your matrix. And let's just take this step by step, piece by piece. If you want to look, the example that I'll be doing is on page 306, page 306, 6.6b. Okay, step 1, find the determinant of your matrix. So let's go down, let's write our matrix. What's our matrix going to be? It is 2, don't like that. It's 2, 1, 4, 3. So let's call this, in the book they call it B. This is matrix B. All right. So now what we want to do with matrix B is we want to find, look at what it says, find the determinant of your matrix. Now if you're looking at the steps in the book, I switch step 1 and 2. You can do the way the book does it, it's fine. You can do the way I do it, it's fine, doesn't matter. You're going to get the same thing. So find the determinant. How do we do that? How do we determine the determinant? Well, we take the diagonal, multiply it. 2 times 3, 6. We take the antidiagonal. 1 times 4 is 4, and we subtract those. And that gives us 2. The determinant is 2. Okay? Write that D-E-T. That's our determinant. That's step 1. Step 1, check. Step 2, find the adjective matrix. Ooh, I don't remember that one. Well, yeah, you do. We just learned it a minute ago, okay? Let's go back up here to it. The adjective matrix of a 2 by 2. Multiply A12 and A21 by -1. So let's go back here, and we're going to write our adjective matrix. I'll do it in purple. We're doing these two. Let me get rid of these lines here. We'll do those two by -1. So we get -1 and -4. We basically just switch those signs. Now what we do is we switch these two. We just swap their position, 3 and 2. This is our adjective matrix. Okay, so the two things that we have here that are important is we have our determinant and then we have our adjective matrix. Okay, and we need both of those. That's step 1 and step 2. Okay, divide each element of the adjective matrix by, check. Step 2 is done. All right, so next, matrix to determine, multiply by the inverse of the determinant. Notice what it says here. It says divide. I've never taught you how to divide in a matrix, right? Well, how do I divide? Let's say I want to divide by 2. I want to divide 6 by 2. Okay, well, that's pretty easy to divide 6 by 2. Did you know that you could also multiply 1/2 by 6 and you'll get the same answer? Did you know that? Or 6 over 1? Because watch what you get. 1 times 6 is 6. 2 times 1 is 2. 6 divided by 2. Okay? So you got the same thing that you started with. So we can do it this way. We can multiply by 1/2. This is the same thing as saying 6 divided by 2. They're both the same thing. So one thing in a matrix, what you can do instead of dividing is you're actually going to multiply. Look what I wrote here. Multiply by the inverse of the determinant. Let's come back down here. What do we multiply by? It's important that you know that it's multiply the adjective matrix. So the one that we got, don't go back to the original here. So we're going to go back to the adjective matrix right here, and we're going to multiply it by the inverse of the determinant. What's the inverse of the determinant? 1/2, because 2 is the determinant. And so we're going to multiply this guy by 1/2. All right, now multiply by, that means all we're going to do here is distribute this thing to all of these. This is a multiplier. This is not multiplying matrix times matrix. This is just multiplying times each element. So let's go ahead and do that. 1/2 times 3. What is that? Well, if you need to come over here and do it, 1/2 times 3 over 1. 1 times 3 is 3. 2 times 2. So our new matrix is going to look like 3 over 2. Let's go here. Well, to do that one, we would 4 over 1. That'll cancel down. That gives us that. But don't forget that's a negative right there. So we get negative 2 over 1 or negative 2. That one would give us negative 2. You can, of course, do these on your calculator. If you have one that does fractions, that'll be fine. 2 times 1/2 times negative 1 basically gives you 1 is going to give me negative 1/2. And then times, what's the last one? Times 2. Okay? And that's going to give us what? That's going to give us 1. 1/2 times 2 always gives us 1. Okay, this is our solution. We've worked all of the last 17 minutes to get to that solution right there. That is what's called our inverse. That's our inverse. What does that mean? Okay, here's what it means. Watch this. This is like magic right here. You're going to love this. So I'm going back here to my original matrix that I started with. 2, 4, 1, 3. 2, 4, 1, 3. That's my original matrix. And now look what I have. Here's my inverse. So if I put my inverse right there and I multiply them together, so I multiply times this inverse, 3/2, negative 1/2, negative 2, 1. Okay? And what is that going to give us? Well, let's take a minute and do it, and let's see. 2 times, remember how to do this? This is not easy, so we have to remember how to multiply this out. 2 times, so we go row times column. Okay, so 2 times 3 over 2. What is that? 2 times 3 over 2. That gives me 6 over 2. That gives me 3. Okay. So my first number is going to be 3. Remember how to do this math right here? This was challenging for some of you. Second one into that, what is 4 times 1/2? 4 over 1 times 1/2 negative is going to equal 2, negative 2. Okay? Plus negative 2 equals 1. Okay? So this is our multiplying our matrix. That gives us 1. All right, now let's go back and do the next one. Done with that one. And you're like, man, Mr. Stu, this is crazy. This is a lot of Yes, I know. Algebra has a lot of fractions in it, and you have to know how to work them, or else you're going to have problems getting the right answer. All right, so let's go to the next one. 2 times negative 2 gives me negative 4. 4 times 1 gives me 4 equals 0. Okay, done with that one. That one was easier. I like them when they don't have fractions, right? Those are easier when they don't have fractions. All right, so let's do the next one. Now we're to row 2 and column 1, and that's going to give us 3 over 2 plus whatever that equals. 3 times 1/2 negative. So negative 3 over 2. Negative 3 over 2. Well, what is that? Negative 3, or 3 over 2 plus a negative 3 over 2, that equals 0. So there we go. We got another 0 right there. Some of you can guess what's going to go in that next spot because you're realizing what we're actually doing. Some of you have no clue what we're doing right now, and others of you, ooh, I know what's going to be in that spot. Okay, you should know what's going to be in that spot because we are making an identity here. This was the identity matrix, and it's going to yield something that we've already talked about. So what do you think is going to be in that spot? Let's see what happens. All right, so we got 1 times negative 2 gives us negative 2 plus 3 times 1 is 3. Negative 2 plus 3 equals 1. There it is. Congratulations, you knew what it was. It's 1. What is that? What did we just get? We just checked our solution, basically, and we just got the, where is it? It's up here somewhere. Ooh, it's way up there. There it is, the identity matrix. We got its identity. So what is the identity of this one right here? 2, 4, 1, 3. What's its identity? Well, its identity is this one right here. This is the identity matrix, okay? So the identity matrix is right here. You multiply it by that and you get identity. You get 1. Okay, remember this equals 1 in matrices. Okay? There is more in this chapter, believe it or not, but I am not going to teach the rest of the chapter. If you want to learn it, then feel free to go ahead and continue on. I just want to know that you know how to invert the matrix. That's the key to this lesson for me. Then it's pretty easy to do the next part, so I'm not going to take the time to go through it. You can look through it if you want, but yeah, there it is, inverting a matrix. All right. If you have any questions, make sure you rewind it real quick and find out what you missed. And try some of these. There's some good practice problems there that you can try. All right. We'll see you later. You have a good one. Bye-bye.